I'm Dave Kassler, KE0OG, welcoming you to the 7th episode of Ask Dave. Today we'll look at practical answers to difficult questions about antennas for your first HF station. So many people have asked me about antenna installations that it's impossible to name everyone, but thanks for all your questions. In many cases, I've tried to answer your questions individually, and in this video, we look at the broad subject. In the 3rd episode of Ask Dave, I showed this diagram of an absolute bare minimum station. We talked about everything that's inside the house. Today, we'll talk about the outside, and that means the antenna. It's often said, and rightly so, that the most important part of a station, other than the operator, is the antenna. It's easy to draw a diagram, but putting up an actual antenna, especially for the first time, can create challenges for the new ham. VHF antennas are relatively small, and sticking a J-pole up somewhere is often straightforward. But on HF, with the frequencies being lower, the required antenna is correspondingly larger. Just to look at the required sizes, an 80-meter dipole is over 130 feet long, 40 meters is 66 feet long, and 20 meters is a somewhat more manageable 33 feet long. So let's look at some situations new generals might encounter. Every amateur encounters restrictions of some sort. The size of your lot restricts the space available. A lack of trees or other tall structures might create height restrictions. And your spouse or your homeowners association might create visibility restrictions. Each of these can be addressed with a compromise antenna of some sort. Let's look at options and what problems they can address. These are by no means all the possibilities, and sometimes getting on the air is a case of ingenuity and sheer perseverance. The fundamental antenna is the dipole, and every antenna is some sort of variation of a dipole. In these diagrams, the black lines are the antenna, the magenta lines are the supports, and the blue line is the feed line. You can make these yourself, or you can buy them ready-made. A classic standard single-band dipole is a half electrical wavelength long. Some sample dimensions are shown in the diagram. The proper height of a dipole is a half wavelength in the air, which means 2 tall supports, very tall in the case of the lower bands. It's unrealistic to expect to get your dipole a full half wavelength in the air. Even on 40 meters, this means over 60 feet. In almost every case, the dipole will be mounted well below this. Now, a form of dipole that requires only one support is the inverted V. You can see how it gets its name from the upside-down V formed by the antenna. The ends are brought down close to the ground. Another form of a single support is the sloper, held up on one end. Note that in all 3 cases, with judicious adjustments, any of these single-band antennas can be used at their resonant frequency without an external tuner, although of course there's no reason not to use a tuner. But we all want to operate on more than one band. It's a reasonably well-known secret that a dipole for 40 meters will also work fairly well on 15 meters. But the 2 key bands to start with are 40 and 20. That means either multiple antennas, which is entirely feasible, or a multiband antenna. Here are a few popular multiband wire antennas, all of which you can make yourself or purchase ready-made. All require 2 supports. The G5RV enjoyed a vogue several years ago and is still available today. Ostensibly, it was a center-fed wire with an open wire line matching section that would present a 50 ohm impedance on all bands. Well, In practice, it requires a tuner, but most certainly can work on all bands, usually 80 meters and up. Another antenna enjoying a current vogue is the off-center fed dipole. You will almost certainly need a tuner for this antenna, but it can be made to work on all HF bands. The last is the most traditional form of a multiband antenna, the trapped dipole. The traps, shown here as black boxes, allow low-frequency RF to pass, thus making the antenna electrically longer, and at higher frequencies block the RF, thus making the antenna electrically shorter. Trapped dipoles are perfectly acceptable antennas. Note that each of these antennas is physically shorter than a half wavelength at the lowest band they cover. Each is a compromise antenna that performs best when high above the ground, a situation that's hard to realize in practice. Although these horizontal antennas perform best when outside in the fairways in the air, they can be adapted to any situation where you can stretch them out all the way. This includes mounting them in attics or fairly close to the ground. If the antenna is a bit too long, you can just let the ends dangle toward the ground. The other option for an initial antenna is a vertical. The ground-mounted vertical is shown on the left. You can make one yourself, or you can purchase multiband verticals from manufacturers. One thing to note, the performance of the vertical antenna is highly dependent on the radial system. Installing a perfect radial system is expensive and requires engineering. Conversely, a few radials are better than none. Note that we can take that same vertical and put it atop a mast, shown here in magenta. Now the radials are reduced to a pair of radials tuned for each band on which the antenna operates. My very first antenna was an installation quite like this, using a high-gain 14 AVQ antenna that was chimney mounted with a few radials. The high-gain 14 AVQ is still available, as are many others from that era. I warn you that antenna manufacturers will tell you that whatever system they have is completely superior to another manufacturer's antenna, and will even offer abstruse technical papers supporting this with various assertions. Take all this with a grain of salt. Now, on the right, we see a vertical antenna with no requirement for radials. I had one of these once, a Cushcraft R5 that worked 20, 17, 15, 12, and 10 meters. It was a great antenna. The R5 is no longer available, but the R9 is, which covers all amateur bands from 80 meters on up, although the bandwidth of the antenna on 40 and 80 meters is rather restricted. That means you have to choose which section of the 80-meter band you want to cover and which section of the 40-meter band. Usually for the higher bands, the antenna will cover the entire band. I point out that these commercial radial-free verticals are expensive, but they can be a great solution if you have only a small lot. If you have height restrictions, it's possible to create shorter verticals using what's called loading, and sometimes that's the only option available. Usually these have base loading provided by an inductor of some sort, and sometimes have capacitive loading at the top in the form of a so-called capacity hat. In theory, only the vertical antenna segment radiates, but in fact, given that this is not only an antenna but also a reactive tank circuit, the circulating currents can be quite high. This results in significant ohmic losses in the conductors, which is then radiated as heat. Also, the radiation resistance of this type of antenna is quite low, sometimes just a few ohms. So the ratio of the radiation resistance to the ohmic resistance can be small, greatly reducing the antenna's efficiency. That said, such antennas are often found in HF mobile installations. They're definitely compromised antennas, but then again, any antenna is better than no antenna. There are other wire antennas. Very popular are loops. This diagram shows two types. The vertical delta loop requires only one support, although this really does need to be pretty tall. If you've got some tall trees, you might be able to string one of these up. The loop offers either vertical or horizontal polarization depending on where it's fed. If you have two supports, such as two trees, you can do a quad loop, meaning a loop with four sides. Again, it will radiate vertically or horizontally depending on where it's fed. And, as a note, loops don't have to be vertical. You can lay these over on their sides. In the case of the horizontal delta loop, you'll need three supports, one for each corner, and in the case of the horizontal quad loop, you'll need four supports. I show these fed with balanced lines, such as window line. In almost all cases, these loop antennas will work on multiple bands as long as you have a robust antenna tuner. Needless to say, there are many other types of antennas, but I strongly suggest you use one of these simple antennas until you get more experience. I've sort of glossed over the concept of supports. Ideally, these get the antenna way up in the air. Some hams have tall trees, but I do note that trees can bend in the wind. This can quickly snap an antenna that depends on two trees for support. You can use rope and pulley arrangements and can look on the internet for examples of how to handle this. If you don't have trees that are tall enough, you can use a system like I do. I got this idea from Lou French, KC0UER. He uses two pieces of chain link fence top rail, each of which is about 10 feet long. You can hook two together to create a 20-foot support. You'll need to hold these in the air with rope or wire guys. Here you see one of mine. I have 3 nylon guys on each and a pulley that allows me to pull up an antenna or let it down for maintenance. By the way, most nylon rope doesn't like sunshine, but you can find nylon rope designed for use in the sun, such as this from DX Engineering. Okay, time for some case studies. Let's look first at my antenna. This aerial picture shows my home. I have a mast on my roof that holds a VHF antenna. I use the mast as one of the supports for my 80-meter full wavelength horizontal loop. There are 3 other support points, each made of 2 sections of chain link fence top rail. So that means that the antenna is only about 20 feet in the air. That's not much, and for 80 meters it fires pretty much straight up, which is great for local NVIS communications within a distance of, say, a couple hundred miles. The antenna is good on 40 meters and gets downright good on 20 meters. I've tried a ground-mounted vertical, but this simple horizontal loop wire antenna outperforms it on nearly every band. For the antenna itself, I used a roll of 12-gauge stranded copper wire that I got from Home Depot. Yes, it's soft-drawn copper, so it does stretch a bit. I have to take up the slack now and then. I carefully tied each of the guy ropes to trees in such a way that the rope is above where anyone walking around the property might hit it, and yet it's low enough on that part of the tree that doesn't bend much in the wind. This picture shows the feed point using a ballon and the coax run down the mast, across the roof, along the rain gutter, down a mast I use for another 2-meter antenna, down to a lightning arrestor at my station ground, and then under the house and up into the shack. By the way, what would it cost to replicate my antenna? I'm not suggesting you do that. In fact, I recommend a dipole or a G5RV, but let's take a look anyway at the costs associated with my loop using all new materials. The antenna wire itself is close to 250 feet long. You can buy a 500-foot roll of 12-gauge stranded wire from Home Depot for around $50. You may want to look for hard-drawn copper or copper weld, but that would be more expensive. There are 4 corner supports, each made of 2 pieces of chain link fence top rail from Home Depot for $100. Then there's the balun. I went for a pretty sturdy one from Balun Designs for $85. For coax, I'm speccing a 100-foot run with connectors already installed for about $40 from DX Engineering. And there will be miscellaneous mounting hardware such as pulleys, hose clamps, duct tape, guy rope, and whatever. That's $345, and that's without taxes or shipping. $400 might be more like it. The next case study looks at what Lou French, KC0UER, has at his station. Lou lives on a city lot near downtown Montrose, Colorado, in a beautiful pre-World War II home. He has no restrictions regarding antenna visibility, and his biggest limitations are space and height.
My name is Lou French, and I am KC0UER. And as far as antenna challenges, I have a kind of a small lot here in town. I have power lines immediately outside my rear property line, and power lines, of course, leading into the house. So I had to arrange my antennas so they didn't cross the power line, couldn't fall on the power line, couldn't get them so tall that if the support went the wrong way, it would fall on and hit the power lines to the back. And so really one of the first things I did was I drew a scale diagram of my lot and buildings and trees and power lines, and then sat and played with that for a while. And I found out that I had just enough room to put in an 80-meter full-length dipole.
So what did you use as antenna supports? How did you get it up in the air?
Well, let's see. Out in front of the house, it goes to a limb of a big cottonwood tree that actually is outside of my property line and kind of between the sidewalk and the street, grows in that little median strip there. The center support is about a 4-inch gray plastic pipe, and that is, I've got a couple guy ropes, 3 guy ropes from that, and it's also braced against the house. And I did not put a pulley at the top of that. I just put a screw eye. It doesn't go down up and down very often. I can lower the center. Lowering the piece that's tied to the tree out front, that's a lot more difficult since it is tied up in the tree. And then in the back, I used several sections, 2 sections of chain link fence top rail, and again with a screw eye bolted, an eye bolt actually through the top of it, and rope coming on down so that I can raise and lower that end also. And as I said, when I go from my property corner to the tree out front, I have maybe 4 feet to spare to make it 132 feet long.
I conclude with the case study of Dick Schultz, KD0ESZ. Dick also lives in Montrose, Colorado, in attractive homes that has covenants forbidding any antennas that can be seen from the street.
Well, first of all, the lot size is 60 by 100 feet, and there's a HOA organization that has antenna restrictions. Essentially, it says the antennas cannot be visible from the front yard. So I have antennas surrounding the house and inside the attic. that if you're out on the road, you cannot see them.
Dick uses attic antennas for 40 and 20 meters.
I have a house that's sort of rectangular, longer one way than the sideways. So I put up a 40-meter dipole, standard copper wire dipole, running the length of the attic. And since it was not quite long enough, the ends of the dipole turn down and drop for about 3 feet on each end. But so the dipole is going the length of the attic, and then across the width of the attic, I put a 20-meter dipole that just goes up the roof and up the top, then back down the other side. And it's both are connected in the middle and come down via coax to my garage and into my radio room here. I do use a tuner with them, but it's an internal tuner to my HF rig. And they're semi-resonant because of the proper lengths for the band, that this will handle anything up to a 3 SWR. If there's a pileup, I have problems. But when somebody's calling and I can hear them clearly, they can usually hear me also.
An 80-meter antenna just wasn't an option for his attic, so Dick used a different approach.
I wanted to get on 75, 80 meter antenna, and it was just too small inside the attic. So what I did is I wrapped a copper dipole wire around just slightly above the gutters of my house. And it's a small, I think it's a 18 gauge wire. And so it's not visible from too far away, but it's running 6 inches above my attic, around the house to the backyard, and then I have it extending out along the fence to make the distance there. And this antenna is approximately 12 feet above the ground, which is not the optimum height for antennas in that area, but it works. Every morning I'm on a weather net where I'm talking 200 miles away to stations on the Front Range, and I have never had a problem getting in and having them not hear me. At first I put it only 2 inches above the rain gutter, and that did not work well. And I found that I just moved it another 4 inches. Now it's about 6 to 8 inches above the antenna gutter, and that seemed to solve my problem. I do have a tuner. As you can see behind me, I have a MFJ tuner, manual tuner.
I asked Dick to tell us about the value of persistence.
Well, think outside the box. Think about something that might work in your situation. Each situation could be different. I've heard people use fence posts. I've heard people use rain gutters that they connect together. And so there must be some way that you can get an antenna up. Maybe you can't get an 80-meter antenna up, but the 40-meter is shorter and the 20-meter is very short. I did remember seeing one person in an apartment building that had a wire strung along his ceiling with a bunch of coils on the end, and he made do. Maybe it's not as good as a 100-foot tall antenna, but it works.
As you can see, both Lou and Dick are using compromise antennas and using them successfully. You can too. So there you have it, an introduction to practical antennas for those new to HF. Send me your questions by commenting on this video, either on YouTube or on my website at ke0og.net. Or submit a question using the form at ke0og.net/ask-dave. Please subscribe and share these videos with your friends. If you'd like, there's a tip jar on YouTube or on my website. I appreciate all the ways you help support this channel. This episode's concluding photograph was taken from the Mullis Pass overlook south of Silverton, Colorado, on a beautiful autumn day. This location along US Highway 550 is about 35 miles south of here as the crow flies. Until our next episode, good luck with your antennas and 73.